This is the review for your topic 1 assessment. Remember to show all work and that this review is worth 10 points extra credit if you turn it in on time. That means you have to turn it in on test day. Number 1. What steps are required to construct a perpendicular bisector of AB? Okay, so first, I'm just going to go through this. All right, so that's AB. So the first thing you need to do is take your compass, and that's not big enough. Draw a circle or an arc with B as its center. Just making sure I do that. And you want to make sure that it's big enough that it goes past halfway. Okay. All right. And you're going to do this from both corners. And then where they cross, that is going to be your perpendicular bisector. Wait for it. Hold on. I don't like that line. Okay. There we go. All right. So there you go. That's how you do it. So I'm just going to erase the rest of this to make it a little easier to see there. All right, and that's how your situation should be looking. So let's write down these steps. So step 1, pretend AB was already there. So don't worry about drawing AB. So after you've established where AB is, you're going to put your compass point on B or an endpoint. Let's do A. Uh, so that it opens past halfway across AB. 2, you're going to draw a circle or arc, then repeat from point B, and then you're going to draw a line through the intersection. So all those steps would basically get you the, not basically, would get you the perpendicular bisector. Okay, so I want you to try number 2, which we already did. What's the first step in constructing a perpendicular bisector of AB? Hopefully you wrote it down. Okay, number 3, what's the area of the composite figure? So, I mean, to be frank, this is a trapezoid, but I'm gonna break it down just for the sake of breaking it down since it did tell me it was supposed to be a composite figure. So I broke it down to a triangle and a rectangle. It looks like we're increasing by 1, 2, 3, 4, 1. So that means this is 4. This is 5, 11. That's 11. So the area of this is 11 times 4, which equals 44. All right, so that's that. And then the area of the triangle, let's see, this oops, is also 4, it looks like. 2, 3, 4. Yeah, you know what? Let me count because some people still don't know how to count 2, 3, 4, and I want to make sure we got it. And then the base is still 11. So the area of the triangle would be 1/2 base times height. 11 times 4 is 44. Half of that is 22. And so now we're going to take those two and add them together. which gives us 66. So there you go. Break it down, find the area of each section you broke it down into, and then add up all the areas. Go ahead and try number 4. All right, number 5. Which equation is perpendicular to the line y equals 1? And I'm about to cheat. Hold up. Blood owl. All right, cool. So I'm doing this so you can see it. I don't know if that'll help, but hopefully it will. So y equals 1. Find the y-axis, find 1, draw a line through it. You could draw a vertical line through it, but then it would go through literally every other line. I'm sorry, every other number on the y-axis. We don't want that. We just wanted to go through the 1, so it has to be horizontal. Also, if you just remember, since it is y equals 1, that would be hoy. So either way, you can see that it's supposed to be horizontal. And then since it is horizontal, we want the perpendicular line. So we want BUX. So this is where we started. This is where we need to end up because it said perpendicular. And we needed to pass through this point. -2, doop doop, 1, 2, 3, 4, 5, right here. Oh, oh no. Hold on. See if I can erase this. Okay, good. And if we draw a vertical line through that point, there it is. And it goes through the x-axis right there. So that's x equals -2. Or we could just look at the point and see that the x value was -2. I'm trying to give you options on how to do these types of problems. Go ahead and try number 6. Number 7, which value is closest to the perimeter of the figure shown on the graph? So this is just like the last one that we did. So I'm going to go ahead and just count 3, 4, 5, 6, 7, 8. Didn't really need to count, but here we are. This was 11. 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 1, 2, 3, 4. And now we need to find, what is that, AB. So I'm going to use the distance formula. And I'm going to set it up first, like I keep telling y'all to do. Set it up first. And then we're going to plug in the numbers for points A and point B. So the coordinates of point A are -5, -1. The coordinates for point B are 6, 3. So when we plug it in, I'm going to do -5 and 6 first, then -1 and 3. Oops, sorry. Let's calculate that. So square root of 11 squared and 4 squared. So that'll be about 11.704, blah, blah, blah. So when we add all that together, it's going to be 11.704, blah, 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 plus 4 plus 11 plus 8. Those are the other sides of this shape. And that will give us 34.7. And I didn't say what to round to, so we're just going to round there. All right, go ahead and give number 8 a shot. Keep in mind that this is increasing by 3s. So that's 3, 6, 9, 12, 15. Okay, so just keep that in mind. Number 8, 9, just kidding. Write the equation of a line that passes through this point and is perpendicular to the line that passes through those 2 points. So, first of all, what's the slope? So we got the change in y over the change in x. And just like when you do the distance formula, the order does not matter as long as you keep these two numbers together. I'm sorry, not these two numbers. As long as the y numbers go on top and the x numbers go on bottom, and they're in the same order as each other. So what I'm trying to say is this could be x1, y1, or this could be x1, y1. Just be consistent, whatever you do. All right. What's that? -6 over -3. That's 2. Okay, so 2 over 1. Now the perpendicular slope, because we're doing perpendicular, yes, yes. The perpendicular slope would be -1/2. That's the one we're going to need to use. And I'm going to set up slope intercept, point slope form, excuse me. So y minus y1 equals m times x minus x1. Now, the y1 and the x1 are coming from this point because that's the point we need to go through. So I'm going to go ahead and plug that in. Again, I'm going to write this formula with bare bones, if you will. And I'm just going to fill in the numbers. So let me use these two numbers. The x was -2, the y is 5, and the slope, we're using the perpendicular slope. So that is the point slope form. I'm going to clean this up a little bit. Y, oh, hold up, my bad. Let me let me fill this in. So the slope that we started with was 2 over 1. The perpendicular slope we got was -1 over 2. And then the equation of point slope form, I'm going to clean this up a little bit. So it'll be y minus 5 equals -1/2. And then that double negative here is just plus. Minus a negative equals plus a positive. And then to change it to slope intercept form, so I'm going to go ahead and do my little plus positive thing right here. To change it to slope intercept form, we are going to distribute this -1/2, making this y minus 5 equals -1/2 x. And then half of 2 is just 1. And negative times a positive is negative, so that's -1. Last thing we're going to do is to add 5 to both sides. And that will give us y by itself equals -1/2 x plus 4. So y equals -1/2 x plus 4 is the slope intercept form. Go ahead and try number 10. Okay, number 11, calculate the midpoint of the line segment formed with the endpoints shown below. Midpoint formula is when you take the x's and subtract them, divide that by 2, then you take the y's, subtract them, and divide by 2. That's the formula. You can check your formula chart as well. So that's going to be -5 minus -3 is -8. Minus a negative is plus a positive. So that's going to be 9. And then if we simplify that further, that'll be -4 and 4.5. Go ahead and give it a shot for number 12. Number 13, classify LMN by sides and angles. Show all your work and explain your reasoning. So we're going to start with the side lengths. LM, so the coordinates of L are 0, 6. The coordinates of N are 6, -6. And the coordinates of M are -4, 4. To find the length of LM, we're going to have to use distance formula. And LM. Okay, so we've got the x's that we need to subtract first, and then the y's we're going to need to subtract second. So let's go ahead and plug in the numbers, and I'm going to change this color to, okay. So the numbers we're plugging in are 0, -4, and then 6, 4. So 0, -4, 6, 4. Okay, just double checking. Okay, so let's go ahead and calculate that. So it's the square root of 4 squared plus 2 squared. And that will be 4.472, etc. Let's try Ln. I'll go ahead and hijack this. Okay. And we're going to plug in L, which is 0, 6, and then N, which is 6, -6. All right. Let's calculate that. So that'll be the square root of 6 squared plus, what's that, 12 squared. So that'll give us 13.416, yada, yada. Oh, Lord, help me. Yada, yada, yada. Let's do NM. And again, I'll erase what we have before to replace it with what we need now. And for NM, let's see, N is 6, -6, and then M is -4, 4, 4. All right, it's looking like 10, 10, is it not? It is absolutely. Okay, so the square root of 10 squared plus 10 squared. Oh, I didn't put a plus sign. I'm firing myself. Okay, there we go. 14.142. Yada, yada, yada. So we can see that this is scaling. All the side lengths were different. It's not isosceles, it's scaling. So let's look at the slope next. So to do the slope, you could just count it on the graph by doing rise over run. So the slope, I'm not doing all that. So for the slope, for this one, we could do the rise over run from the graph, or we could just kind of cheat and take those. So don't forget, change in y over change in x. So irritating. Okay, so it's that 6 minus 4 is 2. And that'd be 4. That simplifies to 1/2. All right. The slope for Ln would be 6 minus -6 over 0 minus 6. And that would be 12 over -6, which is -2 over 1. And for this last one, it's -6 minus 4 over 6 minus -4. So that's -10 over 10, which is -1 over 1. All right, so I see that we have negative reciprocals here and here. That's perpendicular, which means that's a right angle, which means that's a right triangle. And this guy, he's just kind of out hanging by himself. And it's a triangle. None of the sides are parallel, so that makes sense. None of the slopes are equal because none of the sides can be parallel in a triangle. Go ahead and try number 14. 15. Which of the following statements is true or false and why? If each side of the rectangle is increased by 3, so increased by 3, not by a factor of 3, that will triple the perimeter of the rectangle. This is false. Let me show you why. 5 plus 3 is 8. 3 plus 3 is 6, yeah? So the original perimeter would be 5 plus 3 plus 5 plus 3, right? And so that would be what, 8, 8, 16. The new perimeter would be 8 plus 6 plus 8 plus 6. So it's 14 plus 14 is 28. Did that double? I'm sorry, did that triple? Triple. Triple means times 3. 16 times 3 is not 28. So that is not correct. Because in order to triple the perimeter, you would have to increase the length of each side by a factor of 3, not just increase it by 3. You got to multiply by 3 in order to triple the perimeter. All right, go ahead and try number 16. Let's keep it all on the screen. Number 17, two sides of a triangle measure 3 inches and 4 inches. What is the length of the third side if the sides are a Pythagorean triple? Honey, Pythagorean theorem, a squared plus b squared equals c squared. And it said that two sides of the triangle measure 3 and 4. And let's figure out what this one needs to be. Now, when it says Pythagorean triple, we mean that they have to be all whole numbers. All whole numbers. So no decimals allowed. All right, 3 squared is 9. 4 squared is 16. Add that together, that's 25 equals c squared. To get that by itself, we're going to have to, why am I doing that? I'm doing too much. To get c by itself, we got to take the square root of 25, which is 5, which is c. So what is the length of the third side? It's 5. And it's not a decimal. Go ahead and try number 18. Number 18. Don't know why I said that twice. Determine the area of the regular hexagon. Don't forget, area of a regular polygon, any kind of polygon, not just a hexagon, is 1/2 apothem or apothem times perimeter. So we're going to do 1/2 times, this is the apothem right there, 40 times the perimeter. Well, first, how many sides does it have? 3, 4, 5, 6. So that's going to be 6 times one side is just, Lord help me. Lord help me. Y'all really going to let me sit here and make these mistakes? Shame on you. Delete that. Delete that. That's not the apothem. I'm tired. 34.6 is the apothem. This is the doggone side length. Apologies. All right, so we're going to have to do 6 times 40. All right, so let me run through that one more time. 1/2 times the apothem, which is this line. That's the apothem. Times the number of sides. We have to multiply that by how much one side is. That's the perimeter. Just add all the sides up. But all the sides are equal. So just multiply by the number of sides. Any hoozles, let's multiply that out. 34.6. 6 times 40. And we should get 4,152 square centimeters. All right, go ahead and try number 19. Just kidding. Go ahead and try number 20. All right, number 21. The length of each side of a rectangle is quadrupled. Quadruple means multiply by 4. Oh, that's embarrassing. 4. How many times larger is the new area when compared to the original? So let's just say, I'll give you an example, but if you did the assignment, then you already know the answer. Well, you should. Let's just say we got a, I don't know, 5 by 2 here. The area would be 10, right? Now let's say we quadruple the sides. Pretend that's quadruple. So multiply by 4. 5 times 4 is 20. 2 times 4 is 8. The new area would be 20 times 8, which is 160. Well, what happened to the area? It increased by a factor of 10 times what equals 160? 16. So how many times larger? 16 times larger. All right, go ahead and try number 20. Oh, just kidding. Sorry, 22 is different. Disregard. All right, construct the perpendicular bisector of CD. Label the intersection of CD and perpendicular bisector point E. Then describe the relationship between CE and ED. Oh my gosh, that was so much to read. All right, so just like we did on number 1, we're going to make a circle that goes past halfway, and it has to be centered at both. Hold on, too far. At both. That doesn't look right, does it? That does not. Okay. And then you're gonna draw a line. Oh, Lord help me. Draw a line that goes through both of these intersections like that. Is that straight? I don't know. It looks straight to me. Oh no, it's a little bit. It's straight, but it's not centered. All right, bam. And then we have to put the point E. Stop it. There we go. Point E goes here. And I'm gonna erase the rest of this because it's unnecessary now that we have that. You don't need to erase though. You keep it there. Unless you didn't do the whole circle. If you just did the arc, that's cool. So if you just did the arcs like that, that's fine. All right. We know it's perpendicular. I'm gonna put the square. And then we have to describe the relationship between CE and ED. Boom. They're equal to each other. Okay, so C, you could put CE equals ED. You could put segment CE is congruent to segment ED. All right, so something like that.